I am not part of Add Trees or Net Zero Plus, but I'm kind of sort of affiliated with. I'm doing my PhD with Brett and Danny. And I could go into some of the techniques I might be using or planning to use or some sort of basically covering topics that have already been covered by a lot of people here a lot better than I could. So instead, I'm going to kind of do a shorter talk on the sort of subject of my PhD, why I think it's motivating, and kind of how it links to a lot of the conversations that already happened today. Okay, so we're all here because in order to reach net zero, we have to plant more trees in the UK. That's to sequester carbon. There's a lot of other benefits, such as biodiversity and so on and so forth. We have a lot of chats about that. There's a lot of government rules to do this. There's various targets for planting trees, whether it's increased percentage of cover or so many new hectares of trees per year or total number of hectares by 2050. Where we're going to plant them is the topic of a lot of this work. 70% of the UK land area is farmland, so a lot of those trees are going to have to go on farms. So that's kind of the subject of the agricultural model that Brett and Chris talked about. There's an impact for planting those trees because you take some of that agricultural land out of production. Now, you maybe want to take the unproductive land out of production. There are ways to kind of potentially trade off on that, but you are going to take some out and then potentially, I mean, as Chris alluded to, is that based on calories? Is that based on value? Are you exporting some of that carbon that's produced? So you import more, you release more carbon in the process. Lots of questions around this. My question when I sort of looked at the brief for Net Zero Plus was, the assumption is that you're going to replace some of that agricultural land with woodland or forestry. But there is kind of in between that you can potentially do as well. It's called agroforestry. I mean, some have heard of it. It's become more popular in the UK. It's a catch-all term. It is very broad. It is a little vague. A lot of people have different interpretations of it, but essentially it means trees on farms. And my interpretation of it is trees in the productive part of farms, not just the corners or next to the house. There's potential benefits to this. You can store more carbon, but you can also potentially improve biodiversity. There are papers that show that you can. There's more anecdotal. I haven't found so much evidence for this, that it improves hydrology. So you improve drainage in the soil, so it doesn't get quite so damp. When it rains a lot, you retain more moisture, particularly in the air, through transpirations. You can modulate temperature when you create microclimates, so you can actually increase the number of growing days, even if the shade does impact the total yield of the crops underneath. These are a couple of examples. This is from France. So this is sort of a silver arable system where they're growing wheat, I think, under Italian older. This is a bit more common in the UK. There is very little agroforestry being done in the UK. It's done in Europe a bit more. We have less of a history of it. But there's growing interest, particularly in livestock side of things. And there's a growing interest in this. There's potential sort of weather resilience questions, improved yields. There is some sort of anecdotal and a little bit of sort of scientific evidence that you can improve the agricultural yields from this by using it, but not by no means always. And the yield impacts are pretty big if you don't configure the systems right. And then there's also potential for income diversification, particularly with sort of sustainable farming incentive changes, and sort of government and practitioners are kind of showing this. So this year, the Sustainable Farming Incentive Scheme, that is sort of the new agricultural subsidy scheme from the government, is including agroforestry, and they included it this year. At the moment, it's low density and so very low and low density agroforestry, but there will be medium density and high density agroforestry coming online. Details on that are pending, which is frustrating people. But this is a map from the Farm Woodland Forum from an event last year, the first agroforestry show in the UK. That was a whole load of thousands of farmers coming to a site in Wiltshire, I believe, to discuss agroforestry. It's been discussed in academia for quite a while in the UK. There's now a growing interest, in part spurred by government and changing subsidies, in part spurred by interest in the kind of mainstreaming of agroecology in general amongst farmers. So there's a lot of potential for it. There's not a lot of there's mixed evidence. There's a lot of potential for it in the UK. I'm interested in what can it contribute to this question of where do we plant trees. So I'm going to sort of kind of cover what is agroforestry, what's my definition of it, or at least the one that I'm working with in my PhD, and then going on to how we model that and how it might be of interest. So there are several types of agroforestry. As I've said, it's quite a catch-all term. This is not exhaustive, and I'm particularly talking about temperate agroforestry. There's a lot better history of agroforestry in the tropics, but it is very different from how we would do it here, simply because there's much more water and energy floating around. So some would define hedgerows as agroforestry, particularly if there's mature trees in them. Windbrace is another kind of edge feature that's commonly used, particularly in livestock farming. There's alley cropping, where you deliberately put sort of regularly spaced lines of trees in arable or pasture systems. There's wooded pasture, which actually does have a bit of sort of historical. There is a bit of history of that in the UK, particularly up in the Lake District. There's some that's carried on. Orchard grazing is a similar thing to that. Riparian planting, and then food forest is quite a new one. I'm excluding that because I haven't seen much in the way of commercial evidence of that. So I'm more interested in kind of the alley cropping and the wooded pasture sort of framing of agroforestry for my PhD. Food forest is commercially, there's a couple of companies started in the Low Countries in the Netherlands and Belgium, but watch that space. So yeah, I'm interested in kind of this regular in-field agroforestry. In part because that's what I can model as I'll go on to next. So there exist mechanistic agroforestry models for agroforestry. They work very similar to crop models with a kind of an added simple tree model on top. So they have various levels of fidelity. So the simplest version is this yield safe model, and that's what I'm using in my PhD. It essentially assumes that across a hectare, trees are a homogeneous shading layer above a crop. The trees shade the crop, they share water in the soil, and you have a simple crop model and a simple tree model. One Ilcast is kind of a 2D one that's factors in soil layers and crop layers. HiSafe is a very sort of 3D based. I think they've even got some ray tracing software in there as well to factor the kind of 3D structure that's used for kind of real micro modeling on some work being done on orientation of rows of trees north to south, or what effect that has on exposure to the sun and so on and so forth. As I said, I'm using the yield safe model. That's schematized as this essentially. Trees shape the crops and trees share water in the soil, and then trees can modulate the microclimate. That's an optional thing on and off that's just been added. That's mostly through transpiration and the effects of shading. That can be parameterized to arable crops. It takes in daily weather and it produces daily biomass that's accumulated. Mainly radiation and precipitation. If you're doing microclimate, you need some other stuff. Temperatures primarily to switch on and off the growth of the crops. And then tree biomass, crop biomass. You can represent grass as a crop. You can represent livestock. It's essentially an energy balance model based on the biomass of grass. And then you can do soil carbon. There's a kind of simplified version of Rothsey in there as well. Are there any problems with this approach? No? Oh, yeah, unfortunately. This is a figure from a big EU project called Ag4, which is kind of the second generation big analysis and experimentation of agroforestry at an EU level. As is unfortunately commonly the case, an experiment was run with agroforestry. 4 data points were collected, and then this very non-stationary curve was fitted to those 4 data points. Not even particularly well in this case. And they've gone, yep, that's calibrated for that system. Let's move on to the next one. So there's a big question here about, well, nobody's quantified the uncertainty on this calibration, so that's going to be a big task on my PhD. Getting hold of this data is also a bit of a big task for my PhD. That's another conversation. But yeah, there's kind of a sparsity of field data, not a non-existence of it, but a sparsity of it, and it's kind of made more difficult by this sort of other problem of this is a combinatorial problem a bit as well. If you had just a tree model, you could parameterize it to a particular species and you get data on that species. If you have particular agricultural crop, you can parameterize it to that particular agricultural crop, but you potentially also need to calibrate across the combinations of those trees and crops. I've chatted to Brett about this at lunch. Potentially we don't, and there's plenty of ways around that. But still, there's a sort of double sparsity based on trying to capture the interactions between different species of trees and crops. and then also different systems, how they're configured, different management styles. It's potentially quite big. So my research questions are many. I'm going to be focusing on particular ones, but as a result of conversations here, I think there's some links that are maybe worth chatting about in sort of slower time. How to best utilize the sparse field data. So I mean, we talked a lot about Bayesian techniques. I think they're very applicable here, but also how do we utilize additional data? So there is sort of field data from forestry systems and from agricultural systems, as well as models. As well, would it be useful to try and calibrate this to WAFOST or to the Woodland Carbon Code? Can we get satellite data such as leaf area index to factor into this? I'll expand on this where best to measure more agroforestry next, but that's kind of related to, there are, by my estimate, almost 300 trials of agroforestry going on in the UK. The Woodland Trust has set up 265 of those, and they are measuring 0 of them. So there's a huge number of these kind of accidental experiments going on that could be really rich in data. We do the kind of UK, and certainly this university doesn't necessarily have the resources to go and start measuring all of those. If we were interested in pursuing this, I certainly don't have the resources to do so. But is there a way we can kind of prioritize how to do those measurements and potentially what we can get from them? How do we plant more? How does agroforestry compare to planting just woodland and then doing in the next parcel over the agricultural crop you would have mixed in with the agroforestry? Is agroforestry potentially a useful hedging tool in terms of this kind of links to this resilience around climate and weather? Does the shelter from winds prevent losses due to winds? Does the increased number of growing days as an agroforestry system matures and we get more variability in the temperature in the UK, does that potentially protect against those problems? And where in the UK is it sort of suitable to trial agroforestry that can teach us most about agroforestry in a UK context? To kind of expand on that, there are all these experiments going on. How do we prioritize which ones to do? And this is just 90. Nobody has drawn up a single map. That's one of the tasks of my PhD, is just to bring all those site data together. And then, there's potentially a Pareto curve style experiment here around the amount of a single hectare of land you proportion into some proportion trees, some proportion of crops. Is if you slide between sort of 20% trees, 80% crops, or 8% trees, 20% crops, is it a simple linear curve? Is it do you get huge losses? Do you actually get some improved yields? Anecdotally, there's meant to be some improved yields in certain systems, but I haven't seen that from the sort of short experiments I've done running the model. But we'll see. There's potential questions there. That's it. Thank you all very much for your attention. Thank you to Danny and Brett for their supervision thus far. Debbie Hemming's also sort of a supervisor. I started this PhD while I was at the Met Office. I'm no longer at the Met Office, but she's one of the supervisors. Thank you also to Chris. We've talked extensively about these problems. Any questions?